Hi y'all, welcome back to my Model Railroad. No, I'm just kidding, we're working on fun stuff today. I know I promised it months ago, but here's the build guide on the EMD stand stuff. Let's get started. So the throttle requires these 3D printed parts. A little pen spring, a little bit of a 6mm ball bearing, quantities of these screws, which are used across both modules actually, as well as a couple 5x2 magnets for the reverser. The basis of the frame has a couple different parts. You have the subframe itself, which all these extra parts are actually added on the frame. Now this is just because I overlooked them when I first built it. We have the axle standoffs, which is where the controls actually pivot across, which would hold the axles themselves, because all the controls attach to these little things, so that it takes the weight off the potentiometer. It goes into the little things there. And then you have the potentiometer holders. These hold the sensors that actually tell the computer where the controls are, which go in the middle here. And that happens for both the reverser and the throttle. Then on those parts you add the potentiometers here, which those connect to the axle, and those are what the sensors, like that's how it knows where it is. Also, a note on these potentiometers, you will need to solder them. And when looking at the potentiometer like this, they're in order of red, blue, black from left to right. So the leftmost is red, the middle is blue, the black is right, which is 5 volts, data, and ground respectively. And the potentiometers are mounted like this on their little frames. So then after that, it's a little bit of a process to install them. I'll lock this down on a tripod and show you. So first you want to install the potentiometer on the side like this with the shorter potentiometer frame. These are number 4 by 1/2 inch screws, I believe, and it's 2 of them per little frame assembly. Next you're going to take one of the little frames, I think they're the short potentiometer holders, or axle holders, sorry. That gets mounted here. It's a little bit out of order, but next you're going to add this. Remember there's a magnet in the bottom of there. It should attract to the ones that are mounted in the frame. You slide it on with the notch of the reverser facing this way. Just wiggle that into place there. It'll bend a little bit, but it's alright. So once that's in place, you can take the second short mount. I'd recommend adding screws into the holes like this, so that they're kind of like preloaded. Makes life a little bit easier. And then screw those into place. So if the audio is bad down here, sorry. It's my basement, so a lot of machinery going on. I don't got too much control over it. Then, once that's screwed into place, you take this little piece. It's the shorter of the 2 axles. This mounts onto the little control through there, like that, and that allows this to rotate. So that is complete. If you want, you can add a little piece of electrical tape like around the outside of this. That'll create a lot more, well, it'll fill up the spaces so there's less wiggle in it, but it's only a 3-position thing. It's either in the center or it's not. So it's either here, there, middle. You know, it's a bit finicky. Electrical tape is really useful for filling in tolerance gaps that I can't fix in printing because I'm a bad modeler. But where did that reverser key? Oh, there it is. And the throttle is a lot more the same. So first of all, you're going to need a 6mm ball bearing. This is what makes the notches in the throttle. There is a pen spring down here cut down to, I believe, 13mm. About 6 point, or just about 6mm in diameter. A little bit less, doesn't hurt. Just whatever fits in the hole, really. So those get plopped in there. Next, you're going to want to install the potentiometer on the tall frame as such. Hopefully you can see that. So it's going to add some screws to this. Make sure the wires go over the potentiometer. You don't want them to all get caught up in the spinny mechanisms. So place that there, hold that in place, and screw it down. In all frames, the screws don't have to go all the way down if they don't want to, because sometimes they act really funny, you know, because PLA is weird. But basically, you're just trying to hold it down and stop it from rotating in ways that it's not meant to, as such. So, next is the thicker version of the tall axle holder, because the thin one goes here for clearance reasons with the actual shell. It was very tight on space. You had to make some compromises there. So just slide that over the potentiometer and drop it into place. Grab your screwdriver. Again, this little frame here, that's because I forgot to add it to the actual model, and I wasn't going to reprint the whole subframe. That should be included in the version I actually uploaded to the internet. So I believe next is adding these. So this, gotta be a bit more careful about how to explain this one. Hold on. So this is the throttle assembly. You have the handle there. It is bolted through. It's a little bit tricky, but you slide the bolt through one side and you just screw it on the other. So that holds that in place, but allows it to rotate as well. I'm still trying to get spring worked out, but to get the dynamic brakes to work properly and to reduce the amount of friction that's needed in the mechanism, it's counterweighted. So basically, the goal is for when the grip is installed on the handle, this should be perfectly balanced. As long as, well, there's enough friction in the potentiometer itself, but basically if it's in this position, it'll stay in this position. If it's there, it'll stay there. So I used Pinewood Derby car weights for this. I used a bunch of pennies for another one. It's really just add weight till it works, and if you add too much, just take a little bit out. So that takes a bit of trial and error to get working, but it does work quite well for what it's supposed to do. What we're gonna do is place this onto the ball bearing, basically, and then this is going to go in front of that. Don't worry about lining them quite yet. We'll get there. So those just sit. You take this, which is the thin version of the potentiometer holder, not the potentiometer holder, the axle holder, add some screws to that, install it onto the frame. So the flat side goes towards that, and the bent inside goes on the outside, as such. Now, I would like to note that given this is 3D printing, the tolerances aren't perfect. So, to reduce the gap between like the actual axle that fits in here, which is this part, and like the frame so it doesn't wiggle around, I put a little piece of electrical tape right where the notch goes. So the throttle's got a little, or the axle's got a notch on it, so it rotates with the thing. Basically, there's a piece of electrical tape there that just squeezes them together, and that makes it so these don't move independently from each other, because that wiggle room will cause issues later. And the same thing happens inside the axle itself. There's a little piece of electrical tape in there that goes on the potentiometer, ensures that doesn't move. So, do the same thing on the throttle. It keeps stuff from wiggling. It, makes things a lot nicer to fix and post when things aren't reading 5 different positions at once. So, basically, you align the axle here, and you just kind of wiggle it around till it works. Like, yeah, you'll find where it is. And then it will, hopefully, yeah, there you go. If it doesn't align with the potentiometer right away, just turn it a little bit. It'll work. So then, just like that, everything should work. So once in this position is, so you can, if you don't install this, you can install counterweights. I use hot glue personally because it's really easy. But you can install counterweights so that this position and the notches, it'll hold itself. But the goal is for the dynamic brakes, this shouldn't move on its own. So that's what the counterweights are there for. Because if you add friction to solve that problem, it makes the notches feel all mushy and everything. That's no good. You want your nice clicks and all that. So that's how to install the frame. I really hope that was in frame the whole time, but basically the whole assembly should look like this. So you have your axle holders, your axles going between, their potentiometers are in the middle like that with the wires going out. You have those installed like that, and there's a little bit of electrical tape between all the connected parts in terms of the axles, the actual like spinny thingies, and the potentiometers, to ensure things don't get all wacky, because things do get all wacky occasionally. And then from there, all you gotta do is take the big piece, the fun one, put it on top of the frame, use actually number 6 by 3/4? Yeah, something like that. So those just screw down through these little holes in the frame down to the pillars, and to finish it off, you take the grip for the throttle, you line up the little screw hole in it on the back side of the throttle with the screw holes there. I'm pretty sure that the way I did this is you actually drill a hole through that hole, because otherwise it prints weird. If you drill a hole through that hole, then you thread a number 4 screw into there. That'll lock the grip on. Everything's great. And that should be this complete. Also, the wires going out are just 4-conductor solid gauge. You can use whatever you want. I did this to be organized, but there's probably better ways of doing it. All it matters is that your conductors, 5 volts and ground, can be together. Data has to be separate. So those just go out. That goes to the end of the Arduino, whatever. It all connects together anyway. Alright, now on to the brake valve. Now, if you notice any similarities, it's a lot more of the same over here, actually, in terms of the mechanisms that's used to build it. So, yeah, let's tear it down and see how it's done. So, if you were paying attention last time, you should see the pattern here. It is, in this case, actually all identical parts. There are 2 axle holders, and no, actually, I guess technically 4, but it's 2 axle holders and 1 potentiometer holder per part. The difference with these is the potentiometer is mounted like that, so it's with the flat side on this side instead, because there's a lot more space to work with within this module. It's not all crammed together. It's the same difference with axles. The axles are threaded through this way, connected to the potentiometer via these. Use electrical tape to reduce the gap between it. It actually is really good at that. It makes life a lot easier. So, yeah, that's how that's installed. This piece here is just screwed in through the frame like that. This piece here uses a bolt through there the same way that the throttle does, because it's got a pivot as well. Right here is a keyboard switch. Come on. Mirrorless camera problems. So, yeah, there's a keyboard switch just installed in a bracket there. That's for the bail off. It's so, when you go, pop, it bounces back. There are counterweights in both of these, so balanced so that they don't move on their own. This is really important for the independent brake, actually, so it really is just trial and error. Like in this case, you can see I used pennies in there, but the goal is to get this thing with this on it, with this little piece on it, to not move on its own. The notches are done with a little piece here. Again, this is actually printed in place. Like last time, there is the same size of pen spring that goes in the bottom. A little piece goes on top of that. It slips out of its spot a little bit now. I'll probably push out a fix for that later. But yeah, that's really about it. Do you have any questions? My Discord's there. I'll post it in the description if this doesn't make any sense. These screw on via screw holes, the same way these, or the same way that one on the throttle did. There's the top of the frame that goes on top of everything, and it all should be pretty much the same from there. Again, you can probably figure it out. So yeah, I guess this video is already getting really long. It's the same process as the last one. Put electrical tape on everything. Axles go through last. I guess you can do the potentiometers ones first. Really, however it fits together is probably the right way to do it. Make sure that's facing that way. The notches should be like that. Very strong, actually. Kind of too strong, but yep. I guess if on that little doohickey there, you can file down the corners on the top of it. That should mean it slips out of its spot less. Don't quote me on that. Never tried it. Probably should though. So that's the overview for this. All you gotta do is put that back on. All the parts I should have put on screen already. I think I'll do it again if I forgot. But that's it for that. Now these little buttons are they're just printed together. There's a little keyboard switch that goes in the base there. That's glued to here. This is glued to the keyboard switch. So, it's fairly self-explanatory. They're not very good. I highly recommend using actual things or just finding an alternative. But if you're really cheap like me, this is a solution to that problem. So I'll put the models for these. Again, Cherry MX keyboard switch, just glued to there, glued into the frame with the button glued on top. You don't have to glue the button. You probably shouldn't, but they pop off if you don't. It's quite annoying. I could push out the new buttons I made from my EMD stand. It's probably a better idea. I'll probably get that fixed soon. But yeah, don't worry about that. That's it. So all that's left from there is hooking stuff up to the Arduino and fixing it in software. Alright, now we are in post. Not really running my computer, but so this is how you're going to connect it to the Arduino. You have your 4 input potentiometers here with the color scheme. We have 5 volt, ground, black, which is ground. So you have these potentiometers, there's 4 of them. All of the 5 volt pins, which is the leftmost pin, will go to the 5 volt bus on a breadboard. So these all are wired together basically, and that will go to the 5 volt port on the Arduino. Second, you have all the ground wires. All the ground wires go to the ground wire bus here, and they will go to the ground pin on the Arduino. So that's pretty simple. Next, you're going to take all the center pins, which I believe I assigned blue wires to. These go to the analog inputs, which are A0, A1, A2, and A3. A4 and A5 are, if you're doing my EMD vertical stand, which you're not. So you only need 4 of these, and they go to A0 through A4. Keep track of which one goes where. It's not that important. You can figure it out anyways, but you should because it saves a little bit of time. And if you have any buttons, for example, you have one pin going to digital and the other going to ground. If you use internal pull-up resistors, which most Arduinos have, you don't got to put resistors or anything in here, so it's fairly simple. So now I will walk through the code and at least how to set it up for the build that you do. Alright guys, we are in Arduino now. This is where all the fun happens. So it looks a bit intimidating, maybe not, depends how familiar you are, but there's a couple very key things you need to know. These are the pins your stuff connects to. That's defining it for the code. So for example, these are all of the potentiometers which do the rotating things like your automatic brakes, independent brakes, throttle, and reverser. The throttle is combined with the dynamic brake because it's a master controller of the desktop variety. That's just the way they do it. So those, whatever pin you connected it to is the pin you will define it as. A0 is analog pin 0, A3, A2, A1. All your digital pins are here, whatever buttons connect to them. So this is like your horn, your bell, sand, alerter, all that good stuff. These are a ton of variables. You only got to worry about this one here. This is the centers of all the notches that the throttle uses. I know, complicated, but you will determine these experimentally for your specific build because they're all going to be a little bit different because it's a 3D print that I designed, and I can't design anything worth anything. So I'll walk through the process of defining how to get these values. It's pretty simple. This is where you define all your inputs and outputs. The pin is just a variable name, and if it's a button, you do input pull up. If it's just an analog thing, it's just input. LEDs and whatever, right? Those are going to be output. This line of code here, you can determine like what's going on where in the serial. So, for example, I wanted to read A0 for whatever's going on here. Mind you, I'm not using the one I showed you how to build to use it as an example because I currently have something else hooked up. But it will be fine. Trust me. We'll survive. It's the same principles. Alright, so now we're in the serial monitor. For example, ignore all those values down there. That's just the serial communications. So what you're looking for is this little value here. For example, this is the automatic brakes. So wherever the handle is, that's where that value will be read. So for example, if I have my brake in release, it is about 265. You know, it'll fluctuate a little bit. It's alright. There's some leeway there. But basically, that's how you find out where on your control certain spots are. Okay, so you can see that at every notch center, like it is a little bit of wiggle room there, but kind of it rests in the middle. So for filling out this set of variables, the int notch centers, you will start with notch 0 and go through notch 8, I believe. So, for example, if these are opposites because they're different controllers, but if notch 0 is about 475, you'll put it there. If you go to notch 1, whatever value it's like kind of wiggle it around, you'll feel where the center is and you'll write that down too. So go through all 9 notches, and that's how you felt the notch centers. For the brakes, it is the same same process. You will input whatever pin it's connected to, and you will find out, like, for example, this defines where handle off is, because that's what 254 represents in the code. So you'll find basically where, like, what range of values it should be. So basically halfway between suppression and handle off is this value, and halfway between handle off and emergency is this value. Then, for example, this, which is suppression, is where is suppression? It's between these values. Then auto value, which is, I don't remember what this one is. Oh, full service. That's where full service resides. Oh my goodness, I don't remember this at all. But, and then this code here maps out the range of values between minimum suppression or minimum application and full service. So this is where the threshold between release and minimum application is. This is where full service is. So you'll map those values out, and you put this value here, and that's between 1 and 252. I should fix that, but it behaves fine for now. it'll be okay. Emergency is defined as anything, like, basically it's past a certain point, it's going to go into emergency. That's the value there. So that's kind of half between handle off and emergency. That's where that value is. You can find it there as well. Independent maps values. Where is the beginning? Where is the end? And then it maps between those two values. So if you're at release, you put that number here. If you're at full service, you put the number here. Reverser is pretty much the same. Well, dynamics actually is. Where does it start? Where does it end? And then it maps it there. So if you put it into where handle or where dynamics should start, that's this value. If you put it to where where dynamic breaks ends, it's this value, and that's the start end values of the code, or for serial communications. Button logic is, for example, that's momentary. These are all momentary buttons. You just copy that around, change variable names, just stuff like that. Okay, reverser, yay. So here, all right, we found it. Okay, so reverser is, so the reverser, these are the standards I'm following because they're what Run 8 uses. This code's basically for Run 8, but I built everything else off of it. 0 is reverse, 255 is forward, everything else is neutral. So in the code, you are defining where is reverse, which is below a certain value, where is forwards, which is above a certain value, and everything in between is just going to be neutral, which is pretty simple. You just find that moving the lever around wherever it works, it works. So that is everything you should need in the code. For all the other scripts, they are Python based. They will read over serial communications. They'll either send keybinds or send other packets of data depending on what simulator it is. Looking at U-Trains Classic, that's not fun to work with. But that's the basics for everything. If you have any questions, I'll ask in the comments. Maybe I'll get back to you. Or join my Discord server. Link in the description, hopefully. Maybe the pinned comment. I'll get back to you there most certainly. That's where I check most often. So, hopefully you found this useful. Best of luck if you're insane enough to try this. And that's all for me today. Thanks for watching.